Hello, this is Mrs. Spy, and this will be my first video on a set of 3 videos going over power functions. First of all, what is a power function? A power function is a function where you only have one term. It's not always a monomial, it's always you have one term to any power. For example, y equals 6, x to the 6th power is a power function. Y equals 3 to the x to negative 5 is a power function. And you even could have fractional powers, 2x to the 4/3 power. Those are all examples of power functions. Now, there are 9 different possible graphs that a power function can make. And here are the 9 different cases we're going to look at. Okay? So the first case is y equals x. That's called the linear case. And if you look at a graph, of y equals x, you'll notice it's a line passing through the origin. As we increase the power only using even numbers, we get to the second type, y equals x squared, known as the even power function, because all even power functions, x squared, x to the 4th, all make the same shape. Let's see what that graph looks like. That graph looks like, if you've anticipated correctly, based on your knowledge of x squared, to be a parabola. And as we increase the power using even numbers, no matter what the even number is, will always stay as a parabola. In all these cases, will stay as a parabola. And we'll see the other case that popped out. But it's x squared, even, x to the 4th, even, x to the 6th, x to the 8th, x to the 10th, etc. And as the power increases, you'll notice this turning point becomes much, much wider, and even comes to be known as what we call a bend point. What happens if the power is odd? Well, if it's odd, it makes this S shape. All odd functions make this S shape, and as the power gets larger, you'll notice the turn, or the inflection point, becomes more bent. The only exception of the odd power of 1, which you mentioned before, was linear. The first 3 types of power functions are linear, even, and odd. Now let's go into negative exponents. So we've done the linear case, we've done the even case, we've done the odd case. Now let's look at the 2 rational cases. Positive rational, doesn't matter, all negative exponents, because 1 over x is the same thing as x to the negative 1. And 1 over x squared is the same thing as x to the negative 2. Those are both power functions, and they're called rational power functions. And they're also broken up into rational even, and rational odd. So rational even and rational odd. Let's look at both of those. Rational even has this weird shape where it's sort of like a volcano where it shoots up like this, and as the power stays even, it makes the same shape. Now for odd, there's this weird end where they go away from each other. Doesn't matter what odd power we do that's negative, they stay separate. Okay, those are the negative whole integer functions. Let's go on to the next group. What about fractional powers? Now, those have many different cases, mainly 4 different possibilities. One where the bottom number is even, and one where the bottom number is odd. Then, where the bottom number is odd and the top number is even, or where the bottom number is odd and the top number is anything you want it to be. So let's look at all these cases. Look at all these cases. So let's start with 1/2. 1/2 is also known as the square root function. So y equals x, the 1/2 power, you get that. Then if you change it to an odd, you get the other half of the same exact function going in the opposite direction like this. And as you change to an even, you get the 1/2, and you add the odd, you get both halves. Even, odd. Now let's go change, let's keep it as 3. Just change the numerator. 1, 2, 4, 5, 7. Now if you notice, an odd number has this effect, but an even number it becomes parabolic. But when it's small, you'll notice it makes this weird funnier shape, and it's all going towards this parabolic shape. Now, what happens if it's negative? Let's just wrap up. If it's negative, the same exact thing happens. And they're all similar. Okay? Let's go over again 8 cases and wrap up. The 8/9 different types of power functions are as follows. Let's do a summary and we're done. First case is linear. Y equals x. And it looks like this. The second case is even. X to an even power. And it makes a parabola. Odd. It makes this shape, as long as it's not the power of 1. You get this S shape passing through the origin, as long as the power is not 1. Then you get negative even and negative odd. So y to a negative even, I mean y equals x to a negative even, and y equals x to a negative odd. The negative even shape is sort of this volcanic shape, and the odd is similar, just as in the first and third quadrant instead of the first and second quadrant. Now, the last case is where we have fractional exponents. So if you have y to 1 over an even number, you get a square root, or that function, radical, if it's y to an odd number, you get the full S shape on both sides. And as this number increases on top, you get closer and closer to a parabola. Same thing here. As this number increases, you get closer and closer to either the shape like this, or a shape like this, or even something that looks like a shape like that, no matter how tight that turning point gets. And those are the different types of functions you get as power functions. In the next two videos, I'll talk about the effect of using a negative number and the effect of a whole number in front of, or a fraction in front of a power function. I know this video is a little bit longer than my usual ones. Subscribe to my channel, and there's 2 more videos in the set. This is Mr. Spy, signing off.